Good morning, y'all. I want to talk to you today not just about a storm, but about a sequence. And I want to be deliberate about that word because I think it carries information that a single event forecast does not. And I think the communities in the path of what is developing right now deserve to understand the distinction before the first drop of rain falls. A storm sequence is not one bad day. It is not one severe weather event that you shelter through and then emerge from and begin the cleanup process. A storm sequence is a series of atmospheric disturbances arriving in succession, each one interacting with the ground conditions, the soil moisture, the river levels, and the infrastructure damage that the previous one left behind, each one compounding the problem that the last one created. It is the meteorological equivalent of being hit while you are already down, and what the models have been advertising with remarkable consistency over the past 4 days, what the ensemble guidance, the deterministic runs, and the SPC's own extended outlook language are all pointing toward with a level of agreement that demands serious attention, is a storm sequence of that compounding, cascading variety developing across the central and southern United States over the course of the next 7 to 10 days. Multiple rounds, multiple hazard types. Each round arriving before the affected communities have had a meaningful opportunity to recover from the one before it. I have been doing this long enough to know that sequences like this are where the real damage happens. Not just the meteorological damage. The roof damage, the flooded basement damage, but the community damage. The infrastructure damage that takes months to repair. The agricultural damage that takes seasons to recover from. The human damage that does not make the headlines, but reshapes families and neighborhoods in ways that outlast the storm by years. That is what is developing right now. And I am going to walk you through every piece of it. Let me start with the large-scale atmospheric setup, because understanding the architecture of this pattern is the foundation for understanding why the sequence develops the way it does and why it is so persistent. The dominant feature driving this entire sequence is a large-scale blocking pattern that has established itself in the upper atmosphere over the past week, and that the models are in strong agreement will remain entrenched for the foreseeable forecast period. Blocking patterns, situations where the normal west-to-east progression of weather systems gets interrupted by a persistent dome of high pressure that refuses to move, are the atmospheric equivalent of a traffic jam. Weather systems that would normally zip through the country in 48 to 72 hours instead pile up against the block, slow down, deepen, and are forced to take unusual paths around it. The specific blocking configuration now in place is a high-amplitude ridge centered over the western Atlantic, and a companion trough digging deep into the central United States. A pattern that meteorologists call a Rex block when it achieves the right vertical structure, and that has historically been associated with some of the most significant severe weather and flooding outbreaks in the modern record. What this block does, practically speaking, is create a highway for moisture. Gulf of Mexico moisture, extraordinarily rich tropical origin moisture with dew points in the mid to upper 70s, is being pumped northward through the warm sector of each successive disturbance that rounds the base of the trough, flooding the atmosphere ahead of each system with the fuel that severe thunderstorms and extreme rainfall events require. And because the block prevents the pattern from resetting, that moisture transport does not stop after one round. It continues, round after round, day after day, until the block finally breaks down, and the models are not advertising that breakdown happening anytime soon. The first disturbance in this sequence is already on the radar, and I want to walk through it with the kind of specificity that helps you understand not just what it is going to do, but what it is going to set up for everything that follows. Round 1 arrives from the southwest, driven by a shortwave trough rotating around the base of the larger amplified pattern. The severe weather window for Round 1 is focused primarily across eastern Texas, Louisiana, and southern Mississippi, a corridor where the combination of very high surface moisture, a sharpening dry line, and moderate deep layer shear supports supercell thunderstorm development during the afternoon and early evening hours. The tornado threat with Round 1 is not the headline. It is present, it is real, and communities in that corridor need to have their shelter plans ready. But the probability of widespread violent tornado activity is relatively contained compared to what arrives later in the sequence. What Round 1 is primarily going to do, and what makes it critically important as the opening act of this sequence, is drop rainfall. Specifically, 2 to 3 inches of rainfall across a broad swath of the lower Mississippi Valley and the Gulf Coast states, with locally higher amounts of 3 to 5 inches in the most persistent training convection corridors. In isolation, 2 to 3 inches of rainfall across the lower Mississippi Valley in April is not a crisis. The ground can handle it, the rivers can handle it, the drainage systems can handle it. But Round 1 is not in isolation. Round 1 is the first installment of a compounding sequence, and the 2 to 3 inches it deposits into the soil, the creeks, and the river systems of the affected region is the setup for everything that makes rounds 2 and 3 so extraordinarily dangerous. Please understand this clearly. Round 1 is not the event you need to be afraid of. Round 1 is the event that makes the events you need to be afraid of much, much worse. Round 2 arrives approximately 72 hours after Round 1, and this is where the severe weather threat escalates dramatically. By the time Round 2's forcing mechanisms are in place, the second shortwave, ejecting from the base of the blocking trough, the surface low deepening rapidly over the central plains, the warm sector expanding northeastward, the soil moisture across the lower Mississippi Valley is already saturated from Round 1. The rivers are already responding. The creeks are already running elevated. And into that primed, waterlogged landscape, Round 2 delivers the full package. The severe weather setup for Round 2 is, frankly, exceptional. The Storm Prediction Center's extended outlook language for this period is using terms: organized severe weather, potential for significant tornadoes, well-defined warm sector. That, in context, mean the SPC is watching the same model agreement I am, watching and arriving at the same conclusions. The thermodynamic environment for Round 2 features CAPE values in the 2500 to 3500 joule range across the warm sector, dew points in the low to mid-70s, and a low-level jet forecast to intensify rapidly during the evening hours, backing winds at the surface to provide excellent streamwise vorticity for supercell mesocyclones. The kinematic environment, the wind shear profile, is equally impressive, with autographs in the model output showing the kind of long, curved shape that produces supercells capable of maintaining persistent, violently rotating mesocyclones for hours. When the thermodynamics and the kinematics are both running into the extreme range simultaneously, you are not in a slight risk environment. You're not in an enhanced risk environment. You are in a major outbreak environment. And the only question remaining is one of execution, whether the convective initiation, timing, the exact position of the dry line, and the subtle mesoscale boundaries that are impossible to forecast at this range all align in the way the models are advertising. Based on the consistency I'm seeing across multiple modeling systems and multiple ensemble runs, I believe the probability of that alignment is high enough that every community in the path of Round 2 needs to be preparing right now as though the worst case scenario is the forecast. The geographic corridor for Round 2's highest tornado potential runs from central Oklahoma and southern Kansas southwestward through North Texas on the western extent, and northeastward through Missouri, western Tennessee, and into western Kentucky and southern Indiana on the leading edge of the warm sector. That is a large corridor. It encompasses dozens of metropolitan areas and hundreds of rural communities. And within that corridor, I want to be direct about the specific population that concerns me most heading into this event: the rural, mobile home population. There are portions of Oklahoma, Missouri, and Tennessee where a significant fraction of the housing stock is mobile or manufactured housing, and where the population density is low enough that community storm shelters are widely spaced and emergency response times are long. Mobile homes are not shelter from significant tornadoes. I have said this before, and I will keep saying it because the data on tornado fatalities is unambiguous. Manufactured housing is catastrophically overrepresented in tornado death statistics relative to its share of the housing stock. If you live in a mobile home and you're in the path of this system, your preparation plan cannot begin and end with getting into the back bedroom away from windows. Your plan has to include a destination, a sturdy, permanent structure, a neighbor's basement, a community shelter, and you have to know how to get there in the dark, in the rain, with the sirens going off. In under 3 minutes, please identify that destination today. Please drive the route today. And please set up y'all call so that when the tornado warning covers your GPS coordinates at 2 in the morning, your phone rings through everything and gets you moving before the storm arrives. $14.95 for a full year of that protection. The link is in the description of this video. Now I need to talk about Round 3, because Round 3 is the piece of this sequence that I think has the highest potential to produce the most widespread, most persistent, and most devastating impact. And it is the round that is receiving the least attention in the current public conversation about this developing pattern. Round 3 arrives approximately 5 to 7 days into the sequence, as the blocking pattern briefly allows a deeper, more amplified trough to dig into the central United States. By the time Round 3 arrives, the hydrological conditions across the affected region are going to be extraordinary. Round 1 saturated the soil. Round 2 added severe weather and additional heavy rainfall to already saturated ground. River systems across the lower Mississippi Valley, the Ohio Valley, and the Tennessee River drainage basin are going to be running at or above flood stage when Round 3 begins delivering its rainfall. And Round 3, based on what the models are advertising, is the wettest round of the 3. The ensemble guidance is showing a focused corridor of extreme rainfall potential, 4 to 7 inches in the broad swath, with locally higher amounts of 7 to 10 inches in the most persistent training corridors, across a region where the rivers have essentially no remaining capacity to absorb additional water. When a river system is already at flood stage and you add 4 to 7 more inches of rainfall to its watershed, the result is not incremental additional flooding. The result is catastrophic, multi-county, multi-state flooding that closes roads, isolates communities, inundates agricultural land, and in the most vulnerable, low-lying areas puts water into homes and businesses that have never flooded before. The Ohio River, the Tennessee River, the lower Mississippi, the Cumberland. These are systems that, when they crest above major flood stage in the context of a compounding multi-round rainfall event, produce the kind of flooding that takes weeks to recede and leaves a mark on communities for years. I want to take a moment here and talk about the infrastructure impact of this sequence in terms that go beyond the immediate severe weather conversation, because the problems this sequence creates do not end when the last tornado warning expires or when the rain finally stops. They are just getting started. Power outages from the squall line winds in round 2, which in the most aggressive bow echo segments are forecast to produce gusts of 60 to 80 miles per hour across a 500-mile corridor, are going to affect hundreds of thousands of customers simultaneously across multiple states. Utility mutual aid crews from across the region are going to be mobilized to address simultaneous outages in multiple states at once, which means the communities that lose power last are going to wait the longest for restoration, potentially days in some cases. Approaching a week, during a period when temperatures in the warm sector ahead of round 3 are running 10 to 15 degrees above normal. A multi-day power outage in 85-degree heat with high humidity is not an inconvenience for the general population. It is a medical emergency for the elderly, for people on home oxygen and powered medical equipment, for families with infants who cannot thermoregulate, for dialysis patients whose treatment schedules depend on powered facilities that may themselves be without power. Please, if you have elderly or medically vulnerable family members in the affected region, have the power outage conversation with them today. Where will they go if the power goes out for 3 days? Do they have a backup power source for essential medical equipment? Do they have a way to reach you if their phone dies? These are the questions that need answers before round 1 arrives, not after round 2 has already knocked out the grid. The agricultural impact of this sequence deserves its own dedicated discussion, and I want to give it that, because the farming families across the Central Plains, the Mid-South, and the lower Mississippi Valley who are watching this forecast develop are facing decisions right now that have no good options. Spring field work is at a critical stage across the entire affected region. Planting windows for corn, cotton, soybeans, and sorghum are open right now or opening within days, and those windows are not indefinitely flexible. The agronomy does not negotiate. Corn planted 2 weeks past the optimal date in Missouri or southern Illinois does not produce the same yield as corn planted on time. Cotton planted into waterlogged, compacted soil after back-to-back major rainfall events does not establish the way cotton planted into properly prepared seedbed establishes. And the equipment, the planters, the applicators, the tillage tools that farmers have spent weeks getting ready for this window, cannot go into fields that are saturated without causing compaction damage that outlasts the current season. Farmers across this region are going to lose planting days they cannot get back. They're going to watch optimal windows close while their fields sit underwater. And they are going to do it while also managing the structural damage that the wind and hail from round 2's severe weather delivers to grain bins, machine sheds, livestock facilities, and the equipment itself. I am raising this not because there is a meteorological solution to an agronomic problem, but because farming communities in the path of this sequence deserve to be seen as something more than a footnote in the crop damage estimate that appears at the bottom of the post-event summary. These are families. These are operations that took generations to build, and this sequence is coming for them hard. Let me bring this home with the clearest, most direct preparation guidance I can give you, because the whole point of everything I have spent the last several minutes explaining is to make the preparation feel proportional to the actual threat. Not panic, not paralysis, but clear-eyed action taken right now while there's still time to act. Identify your tornado shelter today. Confirm it is accessible. Practice getting there in the dark. Set up y'all call on every phone in your household before you go to sleep tonight. Know your flood-prone roads and know your alternate routes before those roads go underwater. If you are in a low-lying area near any river, creek, or drainage system, monitor your local emergency management's guidance on flood watches and warnings, starting with round 1, because round 1 sets the table for round 3. And by the time round 3 arrives, the flood threat may escalate faster than any alert system can keep pace with. Charge every device. Fill every prescription. Check on your neighbors. Have the power outage conversation with your elderly family members today. And please, every time you encounter water on a road during this sequence, no matter how shallow it looks, no matter how late you are, no matter what is on the other side of it, turn around. The road will still be there when the water recedes. You need to be there too. I am going to be with you every step of this sequence. Live the moment severe weather initiates. Live through every overnight window. Live through the flood threat as the rivers respond. Subscribe to this channel, hit that notification bell, and I will see you all in the live stream. I love every single one of you. Take this seriously. Prepare now. Stay safe out there.